Hey there, YouTube. Good evening. It is April 3rd, 2023. Meteorologist Hunter Anderson here, and we're going to do another quick little forecast discussion for the setup tomorrow, in which I will also be partaking in the chasing of potential storms. We'll get into a little more of that later on. This is not necessarily for the public, the general public, but of course, if you want to watch this because you're interested in weather in general, I mean, feel free. Absolutely. I appreciate it. I appreciate any feedback you guys give as well. I'm sure there are other sources, such as other fellow meteorologists and storm chasers, namely Trey Greenwood, potentially John Hominick, that will also be doing severe weather discussions on this specific event and probably be looking at it in a lot more detail than me, honestly. And they're going to be probably covering both modes as well. I know the latest Storm Prediction Center update has introduced a moderate risk across the Mid-South and the Ozark Plateau on top of the ongoing moderate risk in kind of the similar spot that we saw that high risk develop last week across eastern Iowa and far northeast Missouri and northwest Illinois. Let's get into it, guys, real quick. Looking at water vapor satellite imagery, and we can see, again, real classic western continental U.S. troughing, really strong flow, actually rounding the base of the trough currently, generally speaking, denoted by this kind of region of yellow color, and another kind of southern stream jet streak, if you will, down here across the central southern United States, but really amplified ridging developing downstream of this trough across the eastern half of the CONUS as well. And what is this trough going to do as we move on into the period tonight? All right, as I mentioned before, we have that northern stream of really fast flowing air, especially downstream of this trough axis across the western CONUS. And we have that kind of more southern stream anticyclonically curved jet streak across the southern CONUS into the parts of the Gulf of Mexico. And as we move forward with time, you'll see this pattern continue to amplify. We're increasing our wave height with this trough. And it's actually combining with this southern stream anticyclonically curved jet as this ridging amplifies across the Gulf of Mexico and southeast U.S. Look at this jet streak that develops. Again, we're looking at over 140, 150 knots developing, again, across the central plains. Very similar to last Friday, guys. Very similar. And we're going to see a pretty strong mass response from this throughout the entire column. We should expect to see roughly somewhere in the exit region, left exit region, of this jet streak. And it does get a little more complicated with the addition of this southern portion, or the southern stream jet. May complicate things in terms of potentially where this low exactly develops. However, this general system is going to have really strong baroclinity, and we're going to see this thing tilt with height. We're going to have our 500 millibar low somewhere nearby this jet streak as well. We'll have our 700 millibar trough low all the way down to the surface, continue to inch further eastward. It's going to continue to strengthen as well as we see this mid-level jet streak develop. Let's head on down to 500 millibars and see where that wave's going to be. So this is 14Z Tuesday, 9 a.m. Closed circulation out here across the Intermountain West, and this bowling ball of a vortex. And this is the one thing I've been noticing with trends in model data lately. Compared to 2 days ago, I mean, this was located much further south, and this noticeable shortwave ejection is actually moving over the moist warm sector, and instead of kind of avoiding it completely. This is lagging a lot slower now than before, and it's much further west than before. So that's one thing to note. We don't have that strong of height falls going on across the open warm sector, moist sector, that really ranges from, and you'll see later, from Texas up into the Midwest. These height falls aren't going to be that impressive. In fact, there might even be subtle height rises throughout the day across northern Illinois and central Illinois. They're kind of under the influence more so of this ridge. But generally speaking, like I said, somewhere in the exit region of this A, 500 millibar trough, and B, in vicinity of this fairly strong differential cyclonic vorticity advection, we should continue to see this low pressure strengthening. And as we see over time, we do see additional geopotential height contours as the system continues to deepen and ultimately occlude across the Dakotas. Another thing to note, and this is more so pertaining to the potential of a lead embedded subtle shortwave trough moving through this perturbed broad southwesterly flow across the open warm sector tomorrow. We're going to have to pay attention to see if anything could potentially kick off something in the open warm sector away from any of our surface boundaries. But this is a big question mark. And I know the SPC referenced this in their more recent couple of outlooks. And they mentioned a subtle 500 millibar speed max that's going to be spreading northeastward within this perturbed southwesterly flow. And I believe they're mentioning this little feature here that develops midday across northern Oklahoma, southeast Kansas, and into western Missouri. That's going to continue to spread northeast with time. Looks like by about 21-22Z, the influence of this little shortwave, if you will, should be completely encompassing northern Missouri, perhaps bringing more of its influence into eastern Iowa and western Illinois. It's going to be something to watch. That personally, it looks like the only source of forcing that I'm seeing across the open warm sector right now. Of course, other than potentially reaching convective temperatures, but just because we reach convective temperatures doesn't mean you're lifting. It just means that your air parcel isn't going to resist vertical displacement once that air parcel is lifted. We need to get that lift first and foremost. Where are we going to get that lift from? Could it be from this subtle 500 millibar shortwave right here, northern Oklahoma into Missouri? We'll see. We'll see. Pretty good signal here, pretty good little ripple among the isohypses. Otherwise, questions remain. Questions big time remain regarding coverage of potential severe convection across the open warm sector. And of course, our surface boundaries, you'll see later, are situated a little bit further north from the shortwave trough. So, and once you get to those two to overlap, I would think we're a little bit more certain we should get some deeper convective initiation by that point. But that's going to be later on in the afternoon, early evening by then. Moving on down to 850 millibars. Like I mentioned before, you can see a broad scope of this warm sector. It extends from, looks like eastern Texas all the way up into Iowa, southern parts of Wisconsin, and really, if you want to talk about the broad warm sector, technically speaking, it includes all the mid-Atlantic, southeast U.S., and portions of the lower Great Lakes too. Really, really strong wind flow here, and this is again a response, a mass response to that strong upper system. We'll see our winds continue to increase throughout the period Tuesday at 850 millibars. We're looking at a pretty strong jet from 40, 45, 50, 55 knots all the way across the Ozark Plateau up into the upper Mississippi River Valley. A pretty unstable air here, all right? We're looking at theta E. Theta E is the equivalent potential temperature, or the temperature a parcel of air would have if it was 1, lifted until it became saturated, 2, all water vapor was condensed out, and 3, was returned back adiabatically to the surface, or roughly 1,000 millibars. The theta E, which typically is expressed in degrees Kelvin, is directly related to the amount of heat present in an air parcel, and thus it is useful in diagnosing atmospheric instability. So we're lifting the parcel, we're taking all the moisture out, and we're descending it back down to the earth. Now, where we lift it from is going to vary based off our initial pressure level. Now, here we're looking at 850 millibar map, so we're going to be lifting it from the 850 millibar parcel. Now, you'll see different values show up with the 925 and the surface, but that's where we're going to be lifting from then, the 925 millibar and the surface level, respectively. But anyways, fairly unstable air mass, you'd think, setting up ahead of this low pressure system and along this dry line here across the eastern plains. And south of that, at least 850 millibar warm front. And like I mentioned, because of these strong winds, that 850 millibar warm front is going to be located a lot further north than the surface warm front. Another thing to watch for, and this begins around roughly the 850 millibar level, is going to be our elevated mixed layer. And you'll see this is currently right now, you'll see all this elevated mixed layer air, these really steep lapse rates between 700 to 500 millibars. That's going to roughly span about 3 kilometers or so. But look at this pocket of really high, really steep lapse rates. This is our elevated mixed layer air, and this is going to get evected northeastward across the Midwest with those strong southwesterly winds. And with time, you'll see this continue to move, continue to spread northeast. By midday Tuesday, look at these lapse rates throughout the 3 to 6 kilometer layer. Anywhere from 8 to 9.2 Celsius per kilometer. I mean, that's a stout cap we're going to have across the warm sector and in vicinity of that at least lower level surface warm front. But this is good though as well. This is going to keep a lid on things. This is going to limit widespread deep convection to develop. This is going to only allow the strongest, really the strongest of the strongest updrafts to punch through that layer when the time comes later in the afternoon on Tuesday. Should make chasing a little more easier, at least to focus on specific cells. We're not going to have 10 cells to choose from. We're really probably only going to have maybe 3 or 4. As the Earth continues to heat up throughout the afternoon and we continue to advect low-level moisture northward, we'll see this elevated mix layer slightly erode a little bit as well, and especially as we're lifting that warm nose a little bit too, given our subtle 500 millibar lead speed max ahead of the main trough ejection. All right, looking a little more closely now at the Midwest, mid to upper Mississippi Valley region, we're looking at 925 millibar theta E. So again, we're lifting that parcel up from the 925 millibar level. We're squeezing out all that moisture, lifting it all the way up to about 200 millibars, then we're bringing it back down dry adiabatically. See how much essentially potential energy instability can be tapped into from these parcels. Of course, the warmer the colors, the greater the instability, more than likely. We see a pretty good indication of that cyclonic flow right around this 925 millibar low pressure across northern northwest Iowa. Really strong surge of low-level theta E air coming in just east of it. And now ideally, you want to be right on that kind of bulge region of where that theta E air is coming into. A pretty good example of this would be last year on April 12th, 2022, across northwest and north central Iowa. We had that famous Palmer tornado. Tons of chasers were there. I personally was not. I was playing the triple point, like literally the triple point that was setting up across Sioux City. But that theta E axis, that theta E bulge, was about 80 to 100 miles to my east. And I picked up on that about an hour too late. Didn't see that tornado, unfortunately, but saw some pretty cool storms throughout the rest of the afternoon and evening nonetheless. But missed out on the tornado of the day and really the tornado of the month outside of Andover. But generally speaking, I mean, just looking at this signal, I personally would be picking somewhere within this theta E bullseye, probably just on the northern gradient, honestly. And you can see really strongly backed low-level flow, 30 to 35 knots at 925 millibar level. That's right off the deck, guys. That's probably a pretty good indication of some strong directional and speed shears. You think we have that 100 knot 500 millibar max coming in across. We have our 250 millibar jet at about 140 knots, but down near the ground we have a southeast wind at 35 knots. So you got that veering with height, increasing speed with height as well. That's classic in these springtime storm systems. Let's look a little bit closer at the surface again, kind of using my theta E cheat code, if you will. And we're going to pick some soundings based off what I'm seeing on here. So again, we have that surface low pressure somewhere out here in western Iowa, a pretty good tongue of theta E air coming into just downstream of that low pressure. But our main axis and our bulge of the higher theta E air is located here across southeast Iowa, northeast Missouri, northwest Illinois. So really anywhere from, looks like Kirksville, Missouri, up toward Davenport, Clinton, back westward, somewhere around Cedar Rapids, maybe even as far north as Waterloo. Oh yeah, Waterloo gets into that, just on the warmer side of that theta E ridge or bulge, right before 7 p.m. So let's take some soundings here around 5 p.m. We'll do one kind of right here, at least according to the RAP. Again, this is a little further west from what I've seen compared to some of the other cams. The cams at least get this theta E ridge kind of maximized further east across northwest Illinois, about 150, 200 miles further east compared to at least what I'm seeing on the RAP. But generally speaking, it's the same idea. It's going to be somewhere centered across east central Iowa into far northwestern Illinois. But yeah, let's take a sounding here. It's going to be right around Cedar Rapids, right kind of on the nose of that low-level theta E ridge. And Google Chrome wants me to make Chrome faster, and we're going to hit not now. All right, so we're going to load up this sounding. This is generally speaking around the Cedar Rapids, Iowa area. right on the nose of that theta E bulge. A couple things I note right away. Of course, our updraft conditions, really large cape, and actually a fairly deep, low-level moist layer. I mean, we're not necessarily that close in terms of being saturated near the ground, but we reach that right up here, right around 800 to 750 millibars. But then we dry out pretty significantly up here. A lot of dry air aloft, a lot of moisture down low. A little bit of convective inhibition still that needs to be eroded, and of course we're only going to get there if we A, continue to advect moisture, or B, we increase our heating. We erode our clouds, and we can have that sun continue to heat us up. We're near dry adiabatic with this temperature profile, but not quite there. I think if we were completely dry adiabatic, we'd be closer to about 83, 84 degrees. And that'd probably be pretty close to our convective temperatures too. Yeah, there you go, 83 there at the convective temperature labeled down here. Also, just looking at the hodograph, fairly moderate storm relative inflow winds, a pretty, well, a pure veering with height, and this is almost pure streamwise vorticity as well, near the low levels. And like I mentioned before, speed shear with height continues to increase, as well as the directionality of it continues to veer. And then we get maybe some slight backing aloft, but that's, on the grand scheme of things, fairly insignificant. But this hodograph and sounding, I mean, looking about 1 kilometer up from our LCL, still fairly moist. So this shouldn't really necessarily support more outflow dominant or strong RFD surges, which would be detrimental to potential tornado genesis. This should maintain fairly moist and fairly neutrally buoyant RFDs, which tornadoes prefer. Of course, if that can be offset by the strong low-level shear and veering and storm relative velocity, and we also already have that in place. So that's, I guess, convenient as well. Storm motion, 42 knots roughly, assuming right motion. But our mean wind initially at initiation is going to be roughly 45 to 48 knots. But even using that mean wind vector, guys, these storms should begin to rotate pretty quickly. I mean, we're fairly streamwise already, even using that mean wind vector. Of course, it's only going to increase with storms that turn right of mean storm motion. But this sounding certainly should support all severe hazards. I would think a hail threat first with this really strong instability. Guys, we're looking at 3,000 mean layer cape in early April in Iowa, guys. That is not normal. There is a very good chance we could get some of the more memorable storms of the year again across similar areas that saw some pretty significant thunderstorms, supercells, tornadoes, you name it, back on Friday, unfortunately. But this day certainly has another high ceiling. Let's take another quick sound. I know this is offset here with the screencast, but let's take another sounding. Let's go a little further east, closer into right along the Mississippi River near Clinton, Iowa. We'll see what's pulled up there. Even more veering with height. And this is an 80-degree critical angle. So almost pure streamwise vorticity being ingested into this alleged supercell. Now here is our elevated mix layer that I mentioned. It's pretty steep lapse rates here. And identified by this violet box and whisker symbol, we're looking at 9.2 degrees Celsius per kilometer through this, looks like roughly 2 kilometer layer, starting around 750 millibars or so. Really steep lapse rates atop this inversion. Again, we need to continue to lift this throughout the day. How are we going to lift that up? How are we going to erode this convective inhibition that we see here? Now, again, look at our low-level moisture. That should be plentiful. Should be plentiful to break that cap. Of course, we need some source of lift. And is it going to come via that 500 millibar speed max, any subtle mid-level wave? We're going to find out. But if this is the case, I mean, I expect a fairly significant tornadic supercell, as well as some hail being the primary threats before, of course, wind damage threat evolves with time, which is pretty typical in these situations. Anyways, guys, that's kind of all I really wanted to mull over for you in the meantime. I'm going to have a crew with me tomorrow. I'll be with Riley, and I believe I'll have Tanner Schaff with me in my vehicle, and we may be caravanning with a couple other coworkers, Brandon and Tyler. So our plan right now is we're going to head to the Cedar Rapids area in the late morning, arrive there sometime around noon, 1 p.m., potentially meet up with other fellow chasers meteorologists, such as Nick Stewart, who is a broadcast met down in the Cedar Rapids area. Shout out, Nick, if you do end up grilling for us in the late morning, early afternoon hours tomorrow. Can't wait to see you, buddy. And then we'll continue to monitor really our theta E bulge from there, and wherever that ridge develops, we're probably going to want to be right on the nose of that. That's where I believe the storm of the day is going to be. I know cams do fire off cells here, reaching the convective temperatures across northeast Missouri, but they're going to be separated from that warm front. That warm front's going to be located back up here, probably across I-80. It's going to slowly continue to lift northward, paralleling US 30, ultimately US 20 by around sunset. So we'll see what those storms do as they evolve with time, as they approach that warm front. And the other triggering source for our boundary is going to be out here in the west. We're going to have a dry line situated across southwest Iowa and the northwest Missouri and far eastern Kansas later on in the day. But models continue to mix this dry line boundary out across southwest Iowa. Probably see a bulge going on somewhere here too along that dry line, where we should expect maybe some isolated convection. But again, any convection that would develop out here will be interacting with some pretty substantial shear and a ton of instability. Again, I do expect some potential long track hailers would evolve into a wind damage threat, or could evolve into a tornadic threat too, as they spread northeastward and near that warm front where that stronger low-level shear is going to be located. Anyways, guys, that's all I have for you in the meantime. Thanks for watching. I hope you guys have a blessed Monday, and stay safe out there Tuesday. I hope we picked the right target this time. We didn't see any tornadoes on Friday. We were on that Peoria cell early on in the afternoon. Looked really promising. I don't think it was quite surface base. Produced a ton of hail. We had to stay well downstream of it. It was moving northeast at 60 miles per hour. We wanted to stay well ahead of that hail core. Once we realized that cell wasn't going to do it, we headed southwest towards Springfield. Couldn't get into a safe position for those tornadoes that were impacting communities right in and around Springfield. But my heart goes out to all those, to the victims, to the victims' families, everyone that lost property, livelihood, everywhere across southeast Iowa, all the way into Wisconsin, northern Illinois. There was, unfortunately, a tornado embedded in a QLCS that ripped a roof off a live concert. There was a live concert in Belvidere, Illinois. It ripped a roof off the venue, and it came crashing down into the entire crowd. It injured roughly 40 people and killed a person. I don't know how that happens in this day and age. We need to be better. But again, heart goes out to everyone impacted, all the way down in Arkansas, Memphis area, just Covington, Tennessee, I believe. And it's sad. Again, thanks for watching, everyone. God bless you all.